So now it should be recorded and we can go back to the first presentation. So, first of all, I would like to mention that if we would skip into the models that are expecting that our dependent variable is not continuous cardinal long scale, we must somehow redefine the logic of dependent variable. We will slightly postpone this discussion about this change of definition of dependent variable, and we will briefly discuss about concept of probabilities, odds, and logits, and then we will link this discussion to our discussion about our dependent variable. So you will recognize that we will use these procedures such as computing probabilities, odds, or something what is called logits for our dependent variable. So this is only preliminary information about the process we will need. I will give you, of course, some brief introduction into the logic by words, and as far as I know that this topic is not maybe too easy to understand, so we will also use some real live computations. That's why we have a Microsoft Excel file which is called Survival, and I will also give you some idea for understanding by pictures, so we will prepare also some charts. I will use, I hope, this simple tool, so it means we will use some slide in Microsoft PowerPoint. So, first of all, I guess it wouldn't be too difficult. We will be discussing about probabilities. Maybe before we start, it would be nice if somebody can help me and say what is probability and what is minimum and maximum value of probability. So is somebody able to define the concept of probability and to say what is minimum and maximum value of the probability itself? So what is the probability?
Okay, so a probability can be defined as a well, how likely is it that some event might occur?
Mm-hmm.
And the values are in the interval between 0 and 1. So 0 means that the event is totally unlikely to occur. It's impossible. And 1 is that the event is sure to happen to occur.
Mm-hmm. Yeah, there are also terms sure event and empty event, sometimes in probability theory, and classical definition of probability is that you are dividing number of options that follow the occurrence of the event and number of all options that can happen. For example, if I take, for example, classical coin and I will make a toss for this coin. So there are two sides of coin, and whether, for example, one part, which these are called head and tails in English. So the probability of head is 1/2 as two options can happen. That's the denominator of the fraction for computation probability, and 1 is only one of these sides is head, so that's why 1/2 is probability that I will get head by tossing a coin. So that's the concept of probability in classical sense in statistics. And by this logic, now we will enter to our example in Microsoft Excel, and we will be computing probability on Titanic disaster. So I will switch into Microsoft Excel environment currently. I hope you can see these figures, or they are too small. Can you see my Excel sheet and in little figures or not?
No, I can only see the presentation.
Presentation? Okay, so
I see the presentation.
I will stop sharing and maybe change the sharing. Sorry for that. showing the screen once again. And now you would see Microsoft Excel sheet. Is it okay?
Yes.
Yes.
Okay, thanks a lot. So if something would be incorrect, let me know immediately. Okay, so here are not precise, but approximate data for Titanic disaster. The reason is that first of all, we would compute only by head, and then we will use Microsoft Excel computation. So here we have male row and female row of those who survived, it means yes, or didn't survive on Titanic. So, for example, for male, we have counts 600 didn't survive and 150 survived. For female, the proportion is 150 for non-surviving and 300 for surviving. If we would like to compute probability of survival or non-survival, first of all, we should sum up these figures. So it means compute how many male and how many female passengers were present on Titanic. So in Microsoft Excel, I can only go to this blank cell, D2 in my case, click into sum icon, once again, and I can take this sum, and I can very simply say I have 750 people. For female, the same, or I can just copy and paste this formula, and I can recognize that I have 450 female passengers on Titanic. So that's the total, so I would only type total. And if I would like to compute probability, so maybe I would add one more row. So here it will be observed counts. And here I would be computing probability. So I will maybe copy these titles of rows and columns. So once again, male and female. And first of all, I would like to compute probability for male to not surviving and for surviving. So what could be the probability that male would survive or will not survive? It is quite easy to guess. So first of all, this 600 divided by 750 would be probability that they didn't survive for male, and 150 divided by 750 would be probability for those who survived. So I would take these fractions. So once again, we are now currently discussing about probability of the event that male didn't survive. So number of male that didn't survive divided by total number of male passengers on Titanic. So this probability is approximately 0.8. And if I slightly change the formula for next opportunity to copy and paste this formula, so I will change this D3 into door D and 3. So I will use function key F4 2 times. So now I can very simply copy probability of surviving for male. What would be the probability of survival if we know that probability of non-survival is 0.8?
0.2.
Yeah, okay. Very easy. So I would copy and then only check that this formula is correct. So once again, I'm computing yes, surviving divided by total. Okay, the same for female, so I can only copy formula. So it is 1/3 probability that woman didn't survive, and of course 0.66, 2/3 that some random female from Titanic would survive. So as you can see, for the first insight, these probabilities for male and female are not similar. They are quite different. So it means from female, majority survive, but for man, majority didn't survive. So before we start further discussion, and now that's a short excursus outside from probabilities, we know that maybe somehow male and female variable is related to whether they survived or not. So first of all, we can say there is some relationship between gender and survival on Titanic. So that's the first insight by probabilities. So probability, once again, figure between 0 and 1, and the logic of computation is occurrence of the event divided by all options. 600 divided by 750, for example, for female no option. So that's probability. Now we would go further, and we would switch into the concept of something that is called odd, or sometimes, but it is only layman English, so that's not statistical expression. We can use instead of odd the expression chance. Only for Czech students, I would like to add that in Czech we call odd as šance. So what is the odd? Odd is the ratio of probability of the occurrence of the event and probability of the non-occurrence of the event. So in other words, odd is the ratio of two probabilities. And once again, before we start real life computation, it would be nice to somehow define property of odd. We know that probability, it means individual probability, is between 0 and 1. If you compute the fraction of two probabilities, so it means values between 0 and 1, what can be the result? What can be a range for the odd as the fraction or ratio of two probabilities? What can be the minimum and what can be the maximum? Some idea? So nobody is able to understand what can be the result of ratio of values between 0 and 1.
It could be all the values between 0 and 1.
No. If you take, for example, values such as 0.8 divided by 0.2, what would be the result?
Well, it can lie, like, it can be more than 1.
Yeah, and maximum would be if the first probability of the event would be very big, so it means that probability of the non-occurrence would be very low, so maximum could be plus infinity.
Yeah.
Okay, and minimum could be 0. If you take, for example, probability of some empty event with 0 probability divided by 1, which is opposite event, so it would be 0. So the scale for odd is from 0 up to plus infinity. You should take it as it is. If you still do not understand fully to this concept, you should take it as it is. And now we would be computing odds. So odd. So once again, I would take male and female in my case. And now I would need only to decide whether I would be computing odd for non-survival or survival. So for example, I would decide for non-survival. So we would be once again computing, if I go back, ratio of probability of the occurrence, so it means of non-survival, divided by the probability of non-occurrence, so it means they survived. So first probability divided by the second one, first probability divided by the second one. So I guess before we start computing in Microsoft Excel, somebody can help me to compute odd for male, 0.8 divided by 0.2. What would be the result?
Four.
Or, yeah, or I will, for the first inside, type that it is 4 divided by 1 to remember that this is the ratio. So it is 4 divided by 1. Or in other words, and that's a correct interpretation, probability to non-survive is 4 times higher than probability to survive. So I guess that this fraction 4 divided by 1 easily helps to understand that this is the ratio of 2 probabilities. Okay, what would be the result for female? 0.33 divided by 0.66, or 1/3 divided by 2/3?
0.5.
0.5, or as a fraction, it would be 1 divided by 2, yeah? So this is odd for male and female. 4 to 1, or 4 times the probability to non-survive for male is higher, but for female, opposite is true. 2 times is higher probability to survive. First practical recommendation: if your odd, or later we will be discussing about so-called odds ratio. So if your odd or odds ratio is below 1, this is this case for female, it is easier for understanding and interpretation to reverse the odd. So instead of 1/2, 1 divided by 2, or 0.5, to say it is 2 divided by 1, or 2 times higher, and to reverse categories. So instead of saying that the odd of non-survival for women is 1/2, or 1 divided by 2, I would say that probability of survival is 2 times higher than probability of non-survival. So if my odd or odds ratio is below 1, it is quite good to reverse the fraction ratio and also reverse categories for the interpretation. Is it understandable?
Yes.
Okay. Only to be sure, as we will be using this concept during the logistic regression all the time, so you should be familiar with this very, I hope so, simple logic. So, odd for male, odd for female. Before we would go further, I would like to say that the scale from 0 up to plus infinity is quite asymmetric. So it means that if I would take this scale for odds from 0 up to plus infinity, there is something what I would call middle, and this middle is the value of 1. Why I'm discussing about 1 as the middle of this scale from 0 to plus infinity. If For example, for female, I will briefly change this data, would be 200 of non-surviving and 200 for surviving. Probabilities would be the same, 0.5 and 0.5. And my odd would be currently 1 divided by 1. So this is the middle. If the probabilities are the same for both event occurrence and event non-occurrence, I would take odd 1. So 1 means that probability are equal for two options. And this is something what I would call as the middle of this long scale from 0 up to plus infinity. So if odd is below 1, it means that our event is less probable than non-event. And if the opposite is true, it means that our event is more probable than non-occurrence of this event. So once again, I would change data to original. I guess it was 150 and 300. So it was 1 divided by 2. So that's only discussion, brief discussion about this odd scale and about reversing of ratios below 1 and about middle value, which is 1. Last one comment is that the letter O is quite often in literature used for odd, P is used for probability. So only you should understand to these shortages for our discussion. And now I will switch into the slide 5, and we will be once again repeating the previous step. Previously, we made fraction or ratio of two probabilities for male and for female and computed odd. And now we would be computing ratio of these two odds, and we would be computing something what is called odds ratio, or shortly only OR in English. So odds ratio, it is ratio of two odds. So once again, odd is ratio of two probabilities, and if I make ratio of two odds, I would compute something what is called odds ratio. So I would type OR here, and first of all, I would like to ask you if somebody can help me to compute 4 divided by 1 divided by 1 divided by 2. What would be the result? What is the result of two fractions, 4 divided by 1 and divided by 1 divided by 2? What is the result? Nobody would help me?
Maybe 4 divided by 2.
8 and 1.
8. Maybe we can type 8 divided by 1 or 8 only. Yeah? So this is the odd. So I would maybe differentiate these phenomenons by colors. So maybe I would use this orange, and odds ratio is, for example, in blue. So 8 divided by 1 says that not probability, but odd to non-survive, as this was odd for non-survival. So odds for non-survive for male is 8 times higher than female. But 8 times doesn't mean that probability of non-survival for male is 8 times higher than for female. You can see that the fraction of these two figures is not 8 divided by 1. So once again, it is a ratio of these two odds, not of these two probabilities. So odds ratio means that, once again, odd it means probability of non-survival versus survival for male and female is 8:1. So in other words, this odds ratio is this complicated fraction, 4 divided by 1 divided by 1 divided by 2. So it is finally 8 divided by 1 or 8 only. Once again, I'm using these fractions here only for you to remember that these are fractions. These are not only numbers that are a result of our computation. So in other words, if this odds ratio is 8 times higher odd for non-survival for male in comparison with female, says that for male, it was much more probable to die on Titanic in comparison with female, if we would like briefly rephrase this discussion. Once again, we would use this discussion for setting the scale of odds ratio. So for odds, we discussed that the minimum is 0, maximum is plus infinity, and the middle of the scale is 1, as it is quite a symmetric scale. So now my question is, if I take odds ratio, it would be fraction of two values that are from 0 up to plus infinity. What can be minimum and maximum for odds ratio? What could be minimum or maximum for odds ratio? So if I take some non-negative value and divide by another non-negative value, what can be the result? Minimum and maximum. I guess it would be the same as for odds. So it means minimum would be 0 once again, and maximum would be plus infinity. Do you agree or not?
Yes.
Okay. So once again, for odds ratio, the scale is from 0 up to plus infinity. And once again, I would call it middle value. So the value somewhere inside this range is the value of 1. What is the meaning of 1 in these computations? So once again, I will briefly change these figures, and let's imagine that I would have, for example, discounts. So I would take another picture, and maybe that it would be 300 and 300s for men, 150 and 150 for female. I would briefly recompute probabilities here. Oh, no. Go here. And there is not sum, sorry for that, too quick. So I would compute sum once again. So I must change the formulas. So male, female, probability, no, yes. So I would take this divided by this figure and only change address. So it should be every time Doro D 9. So that's it. That's it. And if I would be computing odds and odds ratio, so I would take this. So for male, it would be 1 divided by 1. So it means these are equalized. The same for female. And odds ratio would be for this case
1, 1.
1, 1.
divided by 1 once again. Sorry for that. Not correct, so I must change it. Okay, so, and what is the meaning of this odds ratio of 1? So, the meaning is very simple. It says that odds for male and female are equalized. The same case here would be, for example, also the case such as, for example, 200s, 400s, 200s, and 400s. Only here I would change slightly these odds. But once again, odds ratio would be 1 divided by 1. So it means that in this case, or previous case, this variable and this variable are not related at all. It means that the proportion, here we have proportions, of male non-surviving and surviving and female surviving non-surviving, here it is, are the same. Just opposite case would be also the same. So 400s, 200s, 400s, 200s. Once again, these proportions for male and female are all the same. Only odds would be here 2 divided by 1 and 2 divided by 1, but still odds ratio would be 1. So odds ratio, in other words, can be interpreted as the measurement of relationship between row and column variable in contingency table. So if odds ratio is 1 or close to 1, it means that these two variables are not related at all. If odds ratio, as in our case, is far from 1, 8 divided by 1 is quite far from 1, so it means that these two variables are somehow related, or in other words, it says, in our case, that the male and female proportion of non-surviving and surviving is quite different. So you should understand to odds ratio as the measurement of relationship between variables in contingency table. So once again, if odds ratio is close to 1, so it means there is no relationship, or in other words, proportion for men and women for non-surviving and surviving is quite the same. If the odds ratio is quite far from 1, so these proportions are quite different, and these two variables are somehow related. And you should remember for this first insight that especially odds ratios will be important for interpretation in logistic regression. So it means instead of classical coefficients in linear regression and their interpretation, if independent variable is increasing by 1 unit, the dependent variable would be increasing by the regression coefficient. We will be, instead of it, in logistic regression, discussing about odds ratio. So it will be our new natural scale for the interpretation. So I hope that everything is clear, but if not, please feel free to ask me. Some questions so far? Okay, if not, so I will once again switch into the presentation, and we will briefly discuss about the concept of logistic regression and transformations of our data. So here it is by words. So in logistic regression, our dependent variable in the easiest case is binary. In some slightly complicated, it is nominal or ordinal variable with more than 2 categories. For binary, we have only 2 variables, 2 values, such as survived or not survived, etc., etc. And if you would apply, and we will show it briefly in a few minutes, if we would apply classical linear model, it would be quite imprecise model for my data. So that's why I need to somehow change my dependent variable and to change the logic of this modeling. So I will only use this slide, and we will try to prepare some picture of these transformations. So first of all, let's start with some easy case. For example, we can follow Titanic example. So I will start with some axis. So here is one. Need only to make it bigger. So here it is. So I would use black color, and maybe it should be wider. Okay, so now it seems correct. So that's the first axis, y-axis, and now we would add x-axis. So here we have some data. And I would add some data, maybe that should be similar to Titanic data. So for us, I would propose that our horizontal x-axis would be the age of Titanic passenger, and we would slightly change in next few minutes the meaning of y-axis. So before we start, maybe the question to all of you, and I guess that you have some knowledge about Titanic disaster, who was more probably surviving on Titanic, older or younger people? Younger people. Okay, so let's imagine that maybe our data, we need some symbol, for example, this small cross would be good. So let's imagine that we would have data like this. So it would be first data point. So I would make the second, third, fourth, fifth. Maybe that's enough. And now I would take maybe some older people. So here we have some data. Let's imagine this is the age, and this is the level of non-surviving and surviving. So it seems that all younger people survived and all older people didn't survive. If I would have such data, and I would like to use classical linear regression, so I can apply regression line. So I would take some line, maybe I would use this axis for simplicity, and I would take this regression line into my data. I guess this would be a regression line implemented into my data. Maybe I will change slightly the color. So this would be my regression line for my data. What is the problem of this linear regression model applied to this binary dependent variable? The problem is quite easy to guess. Only in 2 points, this one and this one, I am correctly estimating the real value 0 or 1. So it means survival or non-survival. For all the rest, I am totally outside from the real values, once again, 1 and 0. This value by this line can be even negative or even big positive, and totally outside of this, only 2 isolated values, 0 and 1. So that's why I am changing the scale from this 0 and 1. It means original only 2 isolated value to the probability. Instead of 0 and 1, probability of the event is the full scale from 0 up to 1. So I have currently slightly longer scale, but still, if I would apply to these zeros up to 1 scale, this linear regression model, I can be still totally outside big positive values or negative values. So that's why instead of these probabilities, as far as you know from previous discussion, we changed into the odds scale. And odd scale says, okay, from this 0 up to 1, I can change the scale from 0 up to plus infinity. It is much better, but still this regression line can go to negative values. So maybe it would be better to change this scale from 0 up to plus infinity to also include negative values. So our last step on this, I would call it transformation tour, would be that we need somehow to change this odds or odds ratio into some values that can be positive as well as negative. So once again, from the scale 0 up to plus infinity, I would like to take scale from minus infinity till plus infinity. And maybe that you know about some functions from your previous study or secondary school, and maybe that somebody can help me to find the function that would change original scale from 0 up to plus infinity to the scale which is starting at minus infinity and finishing at plus infinity. Do you know about some function? Yeah, sorry?
Logarithms?
Yeah, logarithms. Thanks a lot for this. And now we would be briefly discussing about so-called logit. So the reason why we are applying logarithms onto odds or odds ratio is only we would like to change original scale 0 and 1, 0 up to 1 probability, odds or odds ratio 0 up to plus infinity into the scale from minus till plus infinity. And if we take logarithm of odds or odds ratio, it means these values in orange or these values in blue, we would get values that are from plus infinity till minus infinity till plus infinity, and that's our main goal. So the logistic regression model, basic logic is that I would take, instead of original variable, which is usually coded as 0, 1, or another coding is also available. So I recompute into probabilities, into odds or odds ratios. And the last step is that I would take logarithm of odds or odds ratio, and then I'm applying classical linear regression model. So it means some constant or intercept, then the impact of the first variable, impact of the second variable, etc., etc. But dependent variable, it means left-hand side of the equation would be this logit. So first of all, I would like to briefly recap that you cannot mix probability from 0 up to 1. Odd, which is ratio of two probabilities from 0 up to plus infinity. Once again, value in the middle is 1. And logit, it means value from minus infinity till plus infinity, logarithm of odd. So these are three transformations. First of all, computation of probability. Second step is ratio of two probabilities called odd. And the last is logarithm of these odds. So these three transformations are present in logistic regression thinking. Before we would go further and we would start some real-life computations in JASP, I would like only once again to discuss briefly about the scale of logit. So if it is, as we have covered here, from minus infinity till plus infinity, and originally odds or odds ratio were from 0 to plus infinity, with the middle point of 1, we should remember some knowledge about logarithm. And if the middle point for odds or odds ratio is 1, what is the logarithm of the value 1? What I would get if I logarithm the value of 1.
0.
0, yeah. So the scale for logit is symmetric around the 0. So it means values are below or above 0. So it means, in other words, they have negative or positive impact on our variable. For example, in this case, if I can see that younger people usually survived and older people usually didn't survive, I guess that if I would compute probabilities, then odds ratios, etc., etc., so this odds ratio would be below 1, and it means that our logit, so rephrasing into minus infinity till plus infinity logarithm scale, would be negative. And it would mean that if my age is increasing, my probability as well as odds of surviving is decreasing. So at least this logit scale, which is quite special and nearly nobody is able to understand it, has some straightforward interpretation. So it means negative values on this logit scale would mean negative impact of dependent variable on odds or odds ratio or probabilities of our event. Or opposite is also true. So if my coefficient in logit scale would be positive, so the impact of independent variable on dependent variable would be positive in this previously defined sense. So that's all about brief introduction into logistic regression by pictures, computations, and by words. So we can currently finish this presentation. So I will close it. And before we will enter the next presentation, I would start some computations in JASP. So if you can go into JASP, and before the first break, we would try to recompute our Titanic example in JASP. Data file for this task are called simply Titanic CSV. So you can open this Titanic CSV data file in JASP. So here it is. So if you open JASP and data file, so you should have the same data file as I have here. So first column is not important for us. These are names of individual passengers of Titanic. But the next variable we will be using in today's lecture. So first of all, there is a class on Titanic. There are 3 classes, the first one, second one, and the third one. So it means the first one is for the rich people, and the third one is for poor people. The next one variable is about the age of passenger. The next one variable is sex of the respondent. And the last one variable is whether he or she survived Titanic disaster. So before we start to compute, or let's call it recompute, our previously computed example in Microsoft Excel environment, but only figures will be slightly different. So I would start with a very simple introduction into logistic regression idea, and I would try to learn you how we can interpret constant or intercept in logistic regression. So before we start to combine whether he or she survived and gender or sex of the respondent, we would only use survive variable for the first computation, and we will learn how we can understand the intercept or constant in logistic regression. So if you would like to apply logistic regression in JASP, so we would go into regression, classical procedures, and last one option is called logistic regression, and JASP currently is capable only of binary logistic regression. It means logistic regression for dependent variable that has only 2 values. So let's go into this dialog. And here it is. I guess that this dialog is quite similar to linear regression, so it's not difficult for you to understand what should be implemented here. So here is our dependent variable. Here are only two types of independence. First are called covariates, and the second are called factors. If you see these pictures, you can very simply differentiate these two windows. So it means here it is expected to add some variables that are cardinal or continuous scales, and here these factors are those who are nominal or ordinal. If I would rephrase it by different words, so here I would define the so-called categorical variables, nominal or ordinal, and here I would define quantitative or cardinal variables or scales. So here, for example, I can use age as covariate, and as factors I can use, for example, sex and class on Titanic. But before we start computations with independent variables, once again, we would like to learn how we can compute intercept and how we can interpret this value. So first of all, I would only define dependent variable. So I would take survived. And after some seconds or maybe some minutes, I can get results. So first of all, here are some statistics for our model called model summary. We will discuss these statistics later. So currently we will not use this table at all. And now we would like briefly discuss about the second table, including coefficients. Here it is the value of our estimate of the intercept. It is minus 0.651. First of all, before we start to think about interpretation of this value, we must go back into our previous discussion, and let's remember that currently we are not using original data. It means survived or not, zeros and ones. We are not using even probabilities. We are not using odds, but we are using logits. So this value minus 0.651 is in the scale of so-called logits. As it is negative, so it seems that maybe more people didn't survive in comparison with those who survived. Here it is known that survival level is coded as class 1. So it means that another option didn't survive is maybe more probable. That's the first insight into this figure, but it is slightly complicated to infer this information from this value. So maybe for us, it would be much better to take some value which would be maybe the proportion of those who didn't survive divided to those who survived, or opposite. So it means to compute odds of survival together for male and female. So it means for all of these. So these two figures can be divided, and we can compute odd for survival or non-survival. Unfortunately, this is not the default in logistic regression computations usually, so we cannot find such a value in a default table, but we can ask for some improvement. So if I would go down here into statistics, I can ask here for odds ratios. So if I click here into regression coefficients and odds ratios, JASP will recompute it for us. And here we have the first result. Here it is called odds ratio, but currently it is only odd. and it is the ratio of probability of surviving and not surviving currently. And the value is 0.5. And my question is, if somebody can help me to interpret this value, what does it mean, this 0.5?
This means that the odds of surviving is the same like equal?
No, this is not about equality. We are not comparing anything. We are now discussing only about surviving versus non-surviving. So once again, let's try interpretation. So maybe I will help you by another output. So I would go into descriptives. I would take variable survived here, and I would ask for frequency table here. So if I wait a minute, I can go to this frequency table, and for simplicity, I can go here and I can find that the percentage of those who didn't survive is approximately 2/3, and the probability, probability not, but percentage of those who didn't survive is 1/3. I can rephrase it as probability, so 2/3 and 1/3. So if I can see these results, that non-surviving 2/3 and surviving 1/3, so can I currently interpret easily this odds ratio or not?
That means that it is more probable to not survive than survive?
Yeah, and in other words, it is 2 times more probable to non-survive than to survive, yeah?
Yeah.
Okay. One computational trick in JASP, as JASP sometimes is fantastic in changes in data analysis. So if I would like to change this value, it means reverse this value, such as 1 divided by this value. So it means it would be approximately 2. It is not only necessary to recompute it in your head, but it is possible to change this category. Survived level is coded as class 1. It means those who didn't survive is coded as 1. So it means this is the ratio of survived versus non-survived. And we know this is the value below 1, and it is quite complicated to interpret. So maybe instead of model for surviving, we can prepare model for non-surviving. In classical statistical packages, if you would like to change it, you would need to go directly to data matrix and to change coding scheme of original variable by some recoding procedure. In JASP, it is very easy. It is only enough to double click into the variable here on the title, and you can only reverse currently here the order of categories. So instead of the first one is 0 and the second one is 1, you take these arrows up or down and you change the order of the categories. So first category would be 1 and the second category would be 0. And as the second category would be 0, usually logistic regression procedures in statistical packages use the second category or the last category as the category in which we are interested in and compare with the previous one. So currently, I guess that the JASP recomputed our result. Yeah, here it is. And here I can see odds ratio is approximately 2. So it means 2 times is higher the probability for non-surviving in comparison with surviving. You can also see that the order in this frequency table is changed. So the first one code is 1 and the next one is 0. So this is very, very easy trick we will be using repeatedly in JASP. You can very easily, for dependent or independent variable, reverse order of categories, and your interpretation is currently much easier. You can also find that original estimate, which was minus 0.651, is currently in logit scale the same value, only with plus. So this scale is symmetric. This scale, once again, is asymmetric. Instead of 0.9, there was 0.5, etc., etc. So this is reciprocal value of original odds ratio. And once again, for odds and odds ratio, we prefer the interpretation with values above 1. That's why we reversed categories of our dependent variable to improve the interpretation. So once again, the meaning of the intercept currently here is that probability to non-survive is approximately 2 times higher than probability to survive. So that's the meaning of intercept in logistic regression currently in the model where there is no independent variable. Sometimes we call this model with no independence as empty or null model. So currently we are not adding any independence, and the meaning of the intercept is odds ratio for my data as a whole. In next part of the lecture, of course, we will add some independent variables, and we will try to compute odds ratio for female, male, etc., etc. But still, we would be happy to have an option to interpret somehow this odds ratio. It means this intercept, which would be in next cases, maybe odds ratio for male or female. We will see these computations later. So that's the first insight, and as the time is nearly at the end of the first lecture, so I would propose currently to make a break.